My name is Anna. I work as a developer at Hive. I used to be a web developer. Now we call ourselves JavaScript developers because we have gone native. And I'm here to tell you a bit about our journey, about why we decided to use React Native, what kind of code we can share between web and mobile, and in the end a little bit about how we actually go about the sharing. So a little bit about us so that I can explain to you why we decided to start using React Native. We're Hive, also connected homes. We do smart devices and we've got a huge range of devices. Our main product is a thermostat, but we also have light bulbs and all kinds of sensors and plugs and cameras. And just controlling the devices is quite a complex work. But we also have schedules and actions, so like if you open a door, a light bulb gets turned on. So we end up having a lot of logic. And at the moment, we have 3 apps that allow the user to control all of this. We've got the web app, the Android app, and the iOS app. And that means that essentially we need to develop all these things at least 3 times. And that's not mentioning the actual devices, the hardware, controlling bits, and the platform that controls it. So essentially, to develop a new feature, right now we have to involve about 5 or 6 teams to get one thing done. And so we decided to speed up the process that we will unite at least everything on the front end under React. We already had our website in React. We did some preliminary tests with React Native and it seemed like a good move for us in that respect. And when you say that we'll do everything in JavaScript, it usually sounds really good to all JavaScript developers and extremely frightening to anybody else, especially to the native developers who we are practically replacing. So we had to drive a hard sell at our office, obviously, to sort of get people on board with it. And our main selling point, especially for the business, was code sharing. We said we don't have to develop 3 apps anymore, we will develop 1/2, but there will be a certain amount of code reuse between the 2, which will allow us to do much faster delivery. And then we can also lower the costs because we don't actually have to have that many developers. It's easier to hire because we don't need to hire a web developer, iOS developer, and Android developer. We just hire a React developer. And I've heard from people that they found it actually very difficult to hire people because obviously React Native is a new technology and hiring experienced React developers is next to impossible. But actually, we found that if you're a React developer, you can pick up React Native very quickly. And there are quite a few native developers, at least in our company, there are quite a few native developers who were interested in learning React Native. So we sort of got the expertise of both mobile and React and just sort of let people learn React Native. And last but not least, it's kind of a cool technology to try out, at least for the developers. It's kind of a cool thing to do. And so we decided then to do this whole thing of rebuilding our native applications with React Native. And that's obviously a huge amount of work. And so we decided that our main strength would be sharing of the code that we have already written on web. And we had this idea of maybe being able to share UI components, the styling and business logic. And from what I kind of knew about React Native back then, I assumed that we'll be able to share UI components, that styling probably will be difficult to share, and that business logic will be practically impossible because on mobile you have so many different hardware integrations, etc., that probably would not be the case. But I was absolutely wrong. It was kind of the opposite, and I will sort of explain to you how React Native works really quickly because that's where I made my assumption mistakes. Because I didn't realize what React Native actually did. So you've got your app, that's your React app. It looks pretty much like any other React code that you have ever seen. And that sits in a JavaScript runtime. It actually works in JavaScript. It does not get compiled into native code. It doesn't sit in a web view. It actually is running in JavaScript. And that sits in the native environment on the device. And in order for the JavaScript thread and the UI or native thread to be able to communicate, there is a React Native bridge, which is essentially a relatively thin layer that gets all your information from JavaScript threads to native and vice versa. So that's kind of where I made the assumption mistake. I thought it would be compiled, or I thought it would sit in a web view, but actually it's quite a strange hybrid system. So what happens to our components when we try to render them? How do I get from a normal React code, like you can see here, to this, to actually seeing something on a mobile device? Well, there's a little bit of a theory behind React that is quite simple. You've got your app, which is written in JSX, and that gets somehow transformed into a virtual tree during runtime, which basically tells the application, this is what it looks like, these are the components I want to render, this is the state that they are in at the moment. And then we take this blob of data essentially and can render it differently on different platforms. We can render it in web, we can render it on mobile platforms, we can even control hardware with React if for some strange reason we decide that's a thing we want to do. So I kind of thought, well, I can just write one thing and that will sort of somehow magically get transformed into the platforms. And to link these two theories together, you've got the app in JSX. In the JavaScript runtime that gets translated into this tree, this data set. The React Native bridge takes this data and transfers it into the native, and the native bit decides how to render it. And so I thought, well, we'll just write one thing and that will sort of magically get transformed into the UI. But it turns out that it's not that simple when it comes to composing UI. When we think about normal web components, we've got our spans and H1s and headers, etc. And all of these are basically based on the fact that web was originally designed as a document, it was a page, and the semantics were important. It wasn't the interaction. We originally didn't have apps, we just had simple pages that were built to transfer information. Whereas mobile applications were designed to be interacted with. So for example, on the iOS, you can see that we've got UI views and buttons and sliders and labels. And similarly on Android, you've got a very similar set. Yet because those are two different platforms developed by two different companies, they made different decisions when it came to implementing certain UX elements. So for example, on iOS, you have date picker that controls both date and time. On Android, you've got date and time picker separately. And this introduces these differences in platforms, especially between web and mobile, but also different mobile platforms. It introduces this weird puzzle game of how do I actually map one to the other? What does, let's say, a div mean in mobile? Well, it's probably a view, and the text would be a paragraph on web. But there are a lot of components that are just not easily transferable from one to the other. For example, if I have H1, how do I decide how I should render it in React Native? Is it some kind of text with extra styling? Am I losing some semantics, some meaning here? How do I work with accessibility? There are a lot of questions that suddenly arise. And so it's not impossible to figure out how to transfer one from web to mobile and vice versa, but it is a decision you as a company need to make. What do I actually want this to mean on the other platform? And so it makes sense that React Native actually could not decide that for us. And so that's kind of a situation that causes a lot of headaches. We originally thought, oh, we'll just write everything once, and then we somehow transfer it to the other platform, and that just did not happen. There are obviously solutions that try to achieve this. The most prominent one is React Native Web, which is a library that is, by the way, used by Twitter and quite a few, large projects. But they only cover about 70% of components at the moment. So you'd kind of need to pick and choose what you actually want to write in order for it to work, to be able to transfer your React Native code into web. But also we felt like that's maybe, as I mentioned, it's difficult to know how to transfer one from web to React Native and vice versa. And we didn't want a different company to make that decision for us. We wanted to have the freedom to make our own choices. There's also React XP, which is done by Microsoft, but since Microsoft is kind of pushing for Xamarin, we were quite unsure about where that project is heading. So we kind of decided to steer clear away from that and simply rewrite all our components ourselves. So there is not much code sharing going on there for sure. But there are some edge cases which allowed us to share code between the two platforms. One would be like logical components, where you basically are not rendering any sort of end components, you're just sort of deciding some sort of minor logic around your components. So in our particular case, we have a conditional feature component, which essentially just renders things based on feature flags. And here you can see that it just checks whether it should render something, and if it should, it just takes the children components and renders them, otherwise it doesn't render anything. In this case, it doesn't matter if it's web or React Native components because it does not actually care about it. Similarly, there is a bit of a hack that you can use in order to render components correctly, and that is pass your end components as props. So you can have a sort of higher level component that just says, I will render something out, and in props, they will tell me what components these children will be. We wouldn't actually use that like widely because it's a bit of a weird approach, but it works so well for SVGs. SVGs are amazing. I think they are the best way of doing assets, especially on web. But SVGs are essentially XML. They are some kind of HTML code at the end of the day. And there are libraries in React Native to work with them, but you need to tell React Native how to actually render SVGs. So we took all our icons, we transformed them into super simple components, and transformed all of the tags into like capital letters, and then we just inject the right components into all our SVGs. And then we have a map like this. This is our web map, where it says when you see an SVG or a G or a path, render this component instead of it. So there is kind of a way of injecting things so that you can reuse components, but we decided to use it minimally, at least for the moment, because we weren't quite sure what it will do on a larger scale. So the TLDR of this whole section is then the next section would be styling. And styling is a bit of a weird one, because if you ever worked with Android or Swift, you would know that styling in mobile is so different from web, because they fortunately don't have CSS. They don't have to actually face that. Actually, then there is one person in the audience who does like CSS. Oh, there are quite a few. There you go, 3, 4. Wow. But let's face it, the vast majority of people just doesn't want to deal with CSS. Yet, React Native is using CSS in order to style things, which in a way is bad because I personally would not want to deal with CSS, but it allows us to reuse code, and we don't actually need to learn new kind of styling. So the original React Native way of going around this is simply using CSS and JS. So you can see that the CSS at the bottom is an object. It is all camel case, it's not kebab case. There are some weirdnesses in React Native, such as they don't use units. Everything is flexed by default. Everything is flexed into a column by default, which is a bit weird. But at the end of the day, it is kind of like CSS, but not quite like CSS. And that kind of posed a problem for us. Fortunately, we were using styled components on web already, and they also have a React Native version. So you can just take whatever styles you have in web and kind of just use them in React Native. Styled components are quite clever. They can strip out all of the units from all your, all the pixels and points that you might have. It's all stripped out and just uses the number value, and it allows you to just write normal CSS as a text. But there are still some edge cases, such as you still need to use elevation on Android instead of z-index, etc. So there are certain amounts of things we still have to specify for React Native. A huge amount of styles can be reused. And our design team was absolutely amazing when we started developing React Native. They developed a whole design system to help us with this transformation. So it's like a normal design style guide in many ways. You've got your colors defined and all your spaces defined and font sizes and stuff. But they also defined every single screen basically as like a Lego screen. You can just take building blocks. All of these blocks are defined on some sort of minor level. And then we can just use them, sort of drop them into screens, which makes it so easy for us to work with it. And we all absolutely love it. And it allows us to just take, I don't know, variables and all kinds of things and just sort of like drop them into React Native, and it just works. And it's so nice to work with. So the answer for styling is we can kind of reuse it. We can reuse it to a huge degree, but there are things that we still need to extend. Styled components help a lot with this. And then last but not least, there is business logic. As I said, I originally thought that would not be reusable at all because simply native is quite different from web. But it turns out that we still have the native and the JavaScript bit when it comes to React Native. And in terms of native, you still have to do your hardware integrations and use the native SDKs. But then you can reuse all of your JavaScript bits because it just sits in a JavaScript runtime. You can use whatever is written in JavaScript for your application and just use it. So we took all our reader. We are using Saga, so all our Sagas, actions, reducers, selectors, all of that we can reuse. And that's a huge help because we don't have to define business logic again. Everything is already there. Similarly, we can use translations. So all our translations set up and store and everything. We've got, I think, 6 or 7 different localizations. All of that is pretty much just minimal setup and everything just works, which is so nice. And when it comes to hardware integrations and native SDKs, it turns out that although React Native is quite young, it already has all these bridges built. So I don't think that we actually had to do anything at all, maybe like a little bit of integration for camera, but we did very little work on the actual native side because it's already built by other people. And so when it comes to actually writing code for our React Native application, we spent vast majority of time on components and styles, especially on components because we essentially have to rebuild the whole UI. But we can reuse styles to a certain degree, which is already quite helpful. And it helps us to keep the apps consistent because since we're reusing styles, it helps you, although we are building different UI, it helps you keep it look and feel the same. When it comes to business logic, we write very small amount, as I mentioned already. Essentially, it's all just moving our existing business logic into like a shared folder, and that's pretty much it. And there's a tiny, tiny amount of native work, which is usually done by those 2 or 3 people on our team who can actually code native, and the rest of us can like safely stay in the JavaScript world. And just to sum up, we can't reuse UI components, kind of styling, but we can reuse business logic, and that is the biggest strength of React Native for us. So it's all good, and we're all very happy, kind of. And just a tiny, tiny bit on sharing the code. Like I talked about what we can share, but I didn't really say how do we actually do it. So there are several approaches that we all considered. The most straightforward one would be a monorepo, where you just pop everything into the same repository and then just require things from different folders. And then we would have like multiple repos as the other approach, and then share them either using node modules or some kind of similar repository sharing or a custom solution. And we actually went for the custom solution for very strange reasons around we have to use this CI, not that CI at the moment, but we are very desperately trying to move to monorepos, so maybe ignore what we did and just use monorepos. The only problem with a monorepo is that there is no existing good CI solution for them. I actually read today that Sales CI launched like a nice monorepo support, but apart from that, like the Circle CI and Travis Jenkins, they just don't have this out of the box, and you would essentially need to write your own CI implementation. And we just did not have the resources at that time, but it's definitely something that we want to invest into. So we're in a good place with our React Native application. We have just launched it to the first 15,000 customers, and it looks quite good. That's a screenshot from my Android phone, and it actually looks like a decent application. And we've had some first feedback. My favorite is, this is a very easy to navigate app. I have found it much clearer than the old app. And that was a great comment for us because we were literally halfway developing this and being all really scared that it will all blow up. And then someone actually really liked it. And then we had another comment just this morning saying, I don't see the difference. And I was like, that's brilliant. We actually built something in JavaScript and users can't tell the difference between native apps and this JavaScript app. So from that respect, I think that was our biggest fear. It was like, how will this actually work in the end? And it turns out that the users really like it. And that's the best. So yeah, we're very happy. We're launching to our 1 million customers sometime this month. And things are going really well. Thank you very much.